we're going to talk in this one about operational factors, but we are going to use some terms interchangeably. So, for example, metalworking fluid, MWF, metal removal fluid is going to be synonymous with that, because really a lot of the things that I'll be talking about are related more to metal removal fluids, but that doesn't mean the principles can't be applied. Looking at, I got to dump the system, or I got to add a tank side by side, or I've got to, do 100 other things to try and, get this thing under control. Monitor. There's dip slides that are very easy to use. They give you basic information, but it's still much better than not doing anything. At least you have an idea. You can monitor trends. And you should always consult with the fluid manufacturer, obviously, to make sure that if you're going to add a tank side by side, that they're recommending it, that it's compatible, that you know what dosage needs to be used. The tool insert, Sandvik Coromant, again, this is from that training handbook. The inserts need to match the process. Turning, milling, drilling will require generally different types of inserts. The rake angle on the tool, positive and negative, gives you an example of what those look like. That could be another factor depending on the process, and the tool manufacturer is going to be able to advise on that. So these are, again, things for your awareness. We look at surface finish and we talk about, okay, tool choice. So this is something, if you're a metalworking fluid manufacturer, you're thinking, well, the tool is maybe you're thinking, I'm not saying you are, but I'm just saying maybe you're thinking, well, the tool is somebody else's problem. I'm not worrying about what kind of insert and all that they're using. I'm just concerned about my fluid and, making sure it's working properly. But you need to understand this, because the tool type and the geometry that's being used needs to be properly selected. This is just an example, but they have a small footprint. They don't take up a lot of space, and they really can be very effective. I think I've heard people say that they feel that they're probably more effective than like the belt skimming type, which are more kind of the classic, one, but your experience may be different than that. I'm just saying, properly maintained tramp oil removal. The emulsion is losing stability. So it might not be so much you're getting a lot of tramp oil. It could be that the fluid is just starting to separate. It's a emulsifiable oil, or even a semi-synthetic. Maybe the dilution concentration is changing and indicates that you're losing some of that, the active ingredients into, the oil that's kind of breaking out on the surface. This certainly, can be a problem with emulsifiable oils as they start getting used up and you start getting, microbial growth. You start eating up those emulsifiers, and now, you start getting that oil splitting out. The water hardness, said before, the initial water quality might not be bad, but boy, over time, those salts are building up as you get evaporation of the water. That can start to cause that emulsion to start to come apart. So, understanding the hard water tolerance of your metalworking fluid is critical. It might perform great at 125 ppm, but when you get to 500, not so good, so that is something you have to understand. What else here? So check hardness of the dilution water, determine if there may be some changes. Maybe there is a pre-treatment system, but the water softener salts are out, they need to be replaced. Maybe the deionizer cartridges are, used up, and maybe even accumulating microbes. Those things can grow. Just as an overview, a couple of terminology things. So metalworking fluid, or MWF, and metal removal fluid, MRF, are going to be used interchangeably. So let's first look at corrosion. And the format of these slides is there's going to be a possible cause, and then there's going to be possible remedies. And, like anything, I'm not saying that these are all inclusive. These are certainly some things you ought to be thinking about. And there may be others as well, but these are some things to give you kind of a guideline of some things you might want to look at. This is a couple of, things that can be used, obviously, for checking pH. Again, I'm not recommending either one of these specifically, but you have your handheld pH meter, which is great to be able to take out in the field and check, the actual sump or different locations to check your pH. That's the best way to do it. You could also use pH papers, but the problem with those is they're not real accurate. So, if the pH is 8.5, use pH paper, well, it might show up as 8 or 9, but it's not going to show up as 8.5 because it's not calibrated to that accuracy. These are a couple of examples, staining on some different aluminum alloys. The slide on the left was courtesy of Angus, and you can see that in a couple of different systems in a semi-synthetic here, you've got a difference between an MEA, TEA fluid on the top versus one that has an octanolamine. You can see that even though the pHs are comparable, you have far less staining on the bottom just because that particular amine is less aggressive on those alloys. So that's something, again, this is an example of something you can potentially do to make something less corrosive